Hello, today we're going to look at simplifying rational expressions. We're going to do two examples, and we're going to make this relatively quick and easy. So the first example that we're going to do is just a very simple fraction. We're going to do 3/4 plus 5 over 8 minus 5 over 6. Now, a lot of students get confused when it comes to fractions. Fractions are your friends. They always have been, always will be. So the first thing that we want to do is kind of break this down step by step. So you want to initially look at the denominators and you want to try to find what the common denominator is between all three fractions. So we know that a 4 breaks down 2 times 2. We know that an 8 breaks down 2 times 2 times 2. And a 6 breaks down 2 times 3. Now if you remember from past lessons, we want to make sure that we take the largest number. So 2 times 2 times 2. 4 is covered in that, so we don't need to add anything additional, but look here, we have this 3 that needs to be added in for the 6. So what we want to do is 2 times 2 times 2 times 3, which equals 24, is going to be our common denominator between all of these fractions. So let's change colors here really quick. We'll go with an orange. So if we do 3/4, we know that we need to get this to equal 24 down here. Well, 4 times what equals 24? Well, 4 times 6. So we know that it's going to be 3 times 6 over 24. And then our next one here, we have 5 and 8. So we know that 8 times what equals 24 is a 3. So 5 times 3 over 24. And then again, here with this final one, 6 is on the bottom. 6 times what is 24? Well, we know that is 4. So 5 times 4 over 24. Alright, so now we need to actually put these together here. So we've got 3 times 6 is 18 over 24. We have 5 times 3, so it's a positive 15 over 24, minus 5 times 4 is 20 over 24. Okay, so what we do here is that we just do our basic addition and subtraction. I like to do addition first and then subtraction. So 18 plus 15 is 33. Minus 20 is 13. And then our denominator is 24. Now at this point, we have our final answer only because we cannot simplify this any further. You always want to look at your final answer that you believe is the final answer and make sure it can't be simplified further by maybe reducing some numbers or some exponents or anything like that on the more complex ones that we get to later on. Okay, so let's clear that out really quick. On our next one here, we're going to actually look at doing a more complex expression. It's going to be a complex fraction, actually. So what we have here is 7 over x minus 3 minus 2 over 3x all over top of 5 over 3x minus 1 over x minus 3. Now this looks scary at first, and it's really not. Once you break it down into the steps and do them in order, everything becomes rather simple actually. So let's pick another color here. So let's look at our numerator first, and we'll try to figure out how we can simplify this, and then we'll simplify our denominator and move on from there. So when we're simplifying, we know that with addition and subtraction we need to make sure that we have a common denominator at the bottom. So we need to see what our common denominator is. Well, there's really not much that we can do here, especially with the x's. So I think our common denominator is just going to be 3x x minus 3. Okay, so we need to look here at the 7. So x minus 3, we need to multiply by 3x to make that denominator work. So we have 7 times 3x over 3x x minus 3. And then same thing here, our 3x needs to be multiplied by an x minus 3. So we're going to subtract 2, and this is going to be over the x minus 3, all over top of 3x x minus 3. Okay, so pretty simple so far. Now we just need to distribute everything out and simplify from there. Pretty easy peasy. So 7 times 3 is 21x. Alright. And then we have our, let's look at this one first. So 21x minus, and then we have a 2x, and then a positive 6. Now, a lot of students get tripped up here as well. You must look at this negative sign or the subtraction symbol here, because it does apply to the 2, and negative times a negative is a positive. And this is all going to be over top of 3 x minus 3. So we need to simplify it one more time. And the reason being is because if you look here, we have some common factors here. So we got 21x and 2x. So 21 minus 2 is 19x plus 6 all over top of 3x minus 3. So this right here is our final numerator. This is as low as we can get it right now. Yes, technically you could distribute this out. You don't want to though because you want to keep it simple. So now let's look at our denominator. So in our denominator here, we have a 3x and an x minus 3. So just like above, it's going to be the same exact common denominator between these two. So we look at the 3x, we know that we must multiply by x minus 3 to equal that common denominator. So our 5 must also be multiplied by that. So we have 5, and then it's going to be multiplied by x minus 3 all over top of the 3x, x minus 3. Okay, and then we're going to subtract, and then 1, we know this has to be multiplied by 3x to equal the common denominator. So we have 1 multiplied by 3x all over top of, again, 3x minus 3. So we know that 5 times x is going to be 5x minus 15 all over top of the 3x minus 3. Okay, and we have negative 3x here because we have this negative symbol, so we got to make sure we pay attention to that, over top of 3x minus 3. Okay, we'll extend that out. Okay, so we have 5x minus 3x. Well, we know that that's going to equal a 2x. So we have a 2x minus 15 over top of 3x minus 3. So this here is our final denominator. Now, we need to take it a step further. So we have our problem here at this point now simplified. Now we need to, that might be a little too bright. Now we need to look at putting it all together. So we have 19x plus 6 over top of 3x minus 3. Again, completely over top of 2x minus 15 over 3x minus 3. Okay, so now what we want to do is we want to multiply by the opposite of the denominator. So this isn't going to change in the numerator, so we have 19x plus 6 over top of 3x minus 3 multiplied by 3x minus 3 over top of 2x minus 15. Now if you look, all we did was flip this. So we brought this here, we brought this here, and we just reversed it. So that way these two cancel each other out completely because you got 3x minus 3, 3x minus 3. So our final answer comes out to, I'll choose a fun color for this one. Let's do a light purple. So we have 19x plus 6 over top of 2x minus 15. Now, again, at this point, you want to make sure that you can look and see if anything can be simplified. Unfortunately, no, nothing can be simplified at this point. So this is indeed your final answer. Congratulations. You have simplified a complex fraction all the way through, and you have arrived at your result. So as you can see, it's really not that difficult. It's just there's a lot more steps involved that you have to kind of remember, but they're not impossible to remember, especially because it's stuff that you've already been doing. So just make sure that you look at the numerator and denominator, you simplify with the common denominators and get them kind of condensed down, and then once you have all that, you want to make sure you take that final denominator over here, and you want to flip that over, multiply, and then go through and simplify as needed. So if there was exponents or anything like that, we could work with those in here, but in this case we don't need to, so this ends up being our final answer. I hope you enjoyed watching this quick demonstration on simplifying rational expressions. We worked on the rational expression with the fractions before, and then now we're doing a more complex fraction problem. Again, it's all about the steps. If you can remember the steps, it's super easy, it's super simple. Just make sure that you go through each and every time and you follow the same pattern. Ask the same questions and show your work. It'll make it so much easier to catch your mistakes. And again, always make sure to pay attention to the symbols because that can definitely throw you off. So again, thank you for watching. I hope you enjoyed, and I'll see you next time.